To optimize the production of a desired product, chemists often use a large excess of one reactant. The other reactant that is present in a smaller amount is called the limiting reagent. It is consumed first during the reaction. It is termed limiting because it limits the extent of the reaction. The maximum amount of product formed depends on the quantity of the limiting reagent. Once the limiting reagent is fully consumed, the reaction cannot proceed further, and any excess reactants remain unreacted. In a balanced chemical equation, the reactant with fewer moles is considered the limiting reagent. For example, here we have the reaction of hydrogen gas with oxygen gas to produce water. The stoichiometric coefficients in the reaction shows that 2 moles of hydrogen gas react with 1 mole of oxygen gas. The oxygen gas in this reaction is considered the limiting reagent because it has fewer moles than hydrogen gas. In practice, it is unlikely for a reaction to proceed with the same quantity indicated in the balanced chemical equation to give the exact amount of product indicated in the equation. In fact, chemical reactions do not achieve 100% product yield due to several factors. Some reactants may be lost during the reaction process, or the actual quantities of the reactants is less than the required, and many other factors. As a result, the percent yield of a reaction, which is the experimental yield divided by the theoretical yield, is usually less than 100%. But how can we identify the limiting reagent of a reaction if we are giving the amount of reactants in grams? When we are given the amount of reactants in grams, we need to determine the limiting reagent based on the quantities of these reactants, not based on what we can identify from the balanced equation. First, we calculate the possible product in moles for each reactant. Then, we compare them, and the one that produces less product is the limiting reagent. For example, suppose we have 170 grams of ammonia that is treated with 440 grams of carbon dioxide to produce urea and water. To identify which reagent, ammonia or carbon dioxide, is the limiting reagent, we convert the grams of both reactants into moles. Then we calculate the number of moles of urea that is produced from each one of them. Finally, we determine the limiting reagent based on the less moles of product produced. First, we calculate the possible product formed from 170 grams of ammonia. We convert grams of ammonia into moles of ammonia, then we calculate the moles of urea. The molar mass of ammonia is equal to 3 hydrogens by 1 plus 1 nitrogen by 14 equal to 17 grams per mole. So the number of moles of urea produced when 170 grams of ammonia are used is equal to 170 grams of ammonia multiplied by 1 mole of ammonia contains 17 grams of ammonia multiplied by 1 mole of urea produced when 2 moles of ammonia are used, equal to 5 moles. Now we can do the same with carbon dioxide. We convert grams of carbon dioxide into number of moles of carbon dioxide, then we calculate the number of moles of urea. First, we calculate the carbon dioxide molar mass. 1 carbon by 12 plus 2 oxygen by 16 equal to 44 grams per mole. Then we calculate how many moles of urea can be formed using the 440 grams of carbon dioxide. The moles of urea is equal to 440 grams of carbon dioxide by 1 mole of carbon dioxide contains 44 grams of carbon dioxide by 1 mole of urea is produced from 1 mole of carbon dioxide equal to 10 mole of urea. So the number of moles of urea formed when using 170 grams of ammonia is less than the number of moles of urea formed from 440 grams of carbon dioxide. Therefore, ammonia is a limiting reagent.